The ASAP array function allows you to define a large number of structures, whether it be lenses as in a lenslet array, or possibly peens or prisms for something like an LCD backlight display. The advantage of using the ASAP array structure is each of the items within the structure, no matter how many, whether it be 10 elements or 1,000,000 elements, as far as ASAP is concerned, it is a single element. What that allows is for significantly more rapid ray tracing and analysis than if each piece was defined individually. ASAP includes several tools which will help you define these arrays much more rapidly rather than having to build them all individually each time. Additionally, the ASAP array structure allows the position of the arrays to be varied in terms of the spacing, either in a defined fashion or in a random fashion. And right now, let's take a look at how easy it is to define a random array of lenslets within ASAP. And all we need to do is define our basic object. In this particular case, it will be an ellipsoidal bump on the surface. And then we simply tell ASAP that we would like to array those structures, and we'll give it a number of rows and columns. We can also choose to apply an exponential spacing change, either increasing or decreasing depending upon whether or not the exponent is greater or less than 1. We can also allow ASAP to randomize the position within the space defined by that array distribution. So let's take a look at the output. And here's our lenslet array. And what we see is a 6 by 6 array. The spacing between the lenslets is increasing as we go in this direction and this direction due to the exponent command, but that increase in spacing is randomized via the random function. And again, we can create any number of peens or objects on our array in this fashion, making ASAP the ideal tool to use in LCD backlights and other types of analysis.